Hi, Calculus crew. This is going to wrap up the end of the week here. And actually, before I even do any of these, I'm actually going to tell you this. We are not covering anything new today. So if you're like, I think I'd rather just have more time to work on homework, go for it. Or I'll even, you know what, I'm going to color code things today. So basically what you need to know is if we were in class, this is such an important concept that we spent 3 days on it in class instead of 2, right? So we're doing the same thing here, but I would have had people go around the room, and I would have told you, like, green are easy ones, so try your hand at it. I would have told you pink ones are ones with more than one region, and you have to find the area of, like, all the parts that are enclosed. I would have told you blue ones have to do with trig. I would have told you yellow ones are Y integration. So basically, I'm going to do one of each type, and I'll use the color marker of what I'm on, except for yellow. So at the very end, I'll be using orange instead of yellow, because I don't have a yellow marker. So like for right now, I'm about to launch into an easy one. And if you're like, you know, I think I'm good with the easy one, then skip ahead to pink, right, which is multiple regions. Basically just watch what you need to watch today. So, it's all still about finding areas between curves. The green one says y equals 2x squared. Y equals x to the 4th minus 2x squared. And it actually gives us a bound, and it gives us a region. So that's really, really nice, because if I was to go graph this, and I might really quick just to double check ourselves, but my guess is, 2x squared we know is just a parabola that opens upward like this. To the 4th, this definitely goes through at 0. If I factor an x squared out of this thing, my guess is that it goes through like here and here, and maybe it does some sort of like W thing. Well, no. Maybe it goes like, Does it open downward? I might actually have to look and see what this one looks like. Because it definitely hits here and levels off. Unless it does something like this. Might do something like this, is my guess. And then we're finding the area of both of these, which this, I guess, actually is also a multiple region one. That's really interesting. But my guess is that maybe it's symmetrical, so that we could only find one side. So you know what, I'm going to just double check this in Desmos and see what's up. Alright, so y equals 2x squared, and y equals x to the 4th minus 2x squared. Oh, I tell you guys, I'm getting good at this graphing stuff in my head. Would you check this out? So, I don't know if you can see that, but it's like this. So my guess is that we can actually do, the reason the multiple regions one will be different is because a different thing ends up on top. We can actually just do one of these and double it. Let's do the positive side, right? So we can just do the integral from 0 to 2. Which one's on top? The 2x squared minus the x to the 4th minus 2x to the 2nd, right, dx. And if we do this, we're hopefully going to end up with the right answer. Again, if I make any math errors on these, you guys will just have to comment on it and let me know what they are, because I'm doing a bunch of this. It's working in my head. So if we distribute the negative, that's 2x squared minus x to the 4th plus a 2x squared. So that's going to be 4x squared minus x to the 4th from 0 to 2. So I'm going to go backwards. I'm going to get 4/3 x cubed minus 1/5 x to the 5th from 2 to 0. And then I'm going to plug in my 2 and double it, because plugging in 0 gets 0. So 4/3 times 8 minus 1/5 times 2 to the 5th is 32, right? So this is 32/3 minus 32/5. That's interesting. And then I guess we're going to take this times 3, take this times 5, and then we'll subtract them and double it. So what is this to the 3rd? 64, 96. 96 over 15. 132 times 5 should be 160, right? Because 5 times 30 is 150. 160 over 15. And if you subtract those, I believe you get 64. fifteenths. That's just half of it, so if we double it, we're going to get 128 fifteenths. The good news is I do have the answer on the back of these because you guys were doing them in class. 128 fifteenths. Feeling good, friends. Feeling good. So that's the green one. Pause it if you need it. So that's the easy one. And now we're moving on to one with multiple regions. And again, this one kind of had multiple regions, but you just got to be careful which one's on top and which one's not when you do ones with multiple regions. So let's see what this next one looks like. And I doubt they're going to give us, they do not give us a interval. So this is the one with multiple regions here. Negative x cubed plus 6x and y equals negative x squared. I'm going to draw the sketch over here this time so I don't run out of room. Well, this is a downward facing parabola. That I know and I can just draw. Feeling good about that. This thing, if I pull a negative x out, I get x squared minus 6. So I know there's an answer here, and I know there's some answers at root 6. Now what root 6 is, I have no idea, but it's somewhere after 2. So this might be one that's good to just take a sketch of and see what it looks like, because I don't know exactly where this is going to hit. So I'll sketch this guy at Desmos, see what we got. Could we solve it, though, if we set them equal to each other? That might be a good thing to do before we hit Desmos. These both equal y, so we can set them equal to each other. X cubed plus 6x equals negative x squared. Move both of these over here. I'm going to have 0 equals x cubed minus x squared plus 6. Pull out an x. X squared minus x plus 6. X minus 3, x plus 2. So x equals 0, x equals 3, and x equals negative 2. So what this is telling me is, I mean, this is a cubic that looks something like this because it goes down. But it actually tells me that it's meeting at 0, 0. It's meeting at 3 something. And it's meeting at negative 2 something. And I can actually plug in and figure out where this is meeting. At negative 2, it's meeting at negative 4. So negative 2, negative 4. So this thing's coming down. Woo! Missed. It's coming down, meeting right there. And then it's coming up. And it's meeting here. Boom. And then it goes up to somewhere we don't know where. And then at 3, you plug 3 and you get negative 9. So at 3, this thing keeps going down. And then this thing will come up and turn around and it'll be at boom at negative. So 3, negative 9. 0, 0, and negative 2, negative 4. So that means we're finding this area and this area. Whew, did you guys see how I did that without Desmos? It all comes from solving some good equations. I know that I'm supposed to just be using pink, but let's at least use red to tell a little bit of a difference of what we're doing here. So all that comes from setting the two equations equal to each other, solving that with some good algebra, and then plugging the numbers back in. I could have plugged them into either equation and gotten the point. So remember, this isn't y integration. This is just straight old. We have to do two separate ones, though, because we have to find this one where the parabola is on top. So this is from negative 2 to 0, because I'm not doing anything fancy with y integration. The parabola is on top, and I'm going to subtract out the cubic. This one, the cubic's clearly on top and the parabola's on bottom. So from 0 to 3, the cubic is on top, and then I'm subtracting out the parabola on bottom. Boom, there we go. And I'm going to have to add those two together. Whew. Well, this one's already ready to move backwards, so why don't we do this one first and then we'll head back up here. So this is negative 1/4 x to the 4th plus, that's at least nice, right? 3x squared. Took that backwards, you get 6x. And then this one's plus 1/3 x cubed from 0 to 3. 0 is going to be 0, which is nice with polynomials. 3 is gross. Negative 81/4 plus 27. And and then 27 divided by 3 is 9. So that's 36 minus 81 fourths. I mean, I could get a common denominator, but I know that 4 goes into 80 20 times, so this is 36 minus 20 and a fourth, and I think I'd rather do that. Because that's 26, 16, 15 and 3/4. 15 and 3/4 is this part. Now I gotta finish this guy. So we're gonna distribute this in, and so we're gonna get a plus x cubed, and then we're gonna get a minus 6x. So this will be negative 1/3 x squared, or x cubed, plus 1/4 x to the 4th, minus 3x squared, right? In between -2 and 0. Man, I might have to erase this. Hopefully you guys had a good job looking at it, or you've had plenty of time to look at that, hopefully. Or you paused it and felt good about it. Because I gotta go up here with some work here. Plug in 0, gonna get 0, so I'm gonna have subtracting, though, whatever I get when I plug in -2. -2 cubed is -8, but times a -3rd is 8/3. -2 to the 4th is 16 positive, divided by 4 is 4. And then -2 squared is 4 times -3 is -12. So if I distribute this, I'm going to have -8/3, which is -2 2/3, minus 4 plus 12. So 12 minus 4 is 8. 8 minus 2 2/3 is 5 1/3, right? 6 minus 2/3, 5 1/3. So boom. Now I just have to add 15 1/3 plus 15 3/4. And we got it. So what is that? 15 and 5, that's 20. And then 3/4 plus 1/3. That's the only place where we need to get a common denominator. So that's 9/12 plus 4/12 is 13/12. So that'd actually be 21 and a 12. Should we see how we did? Hopefully we did it right. 21 and a 12th. I kept it as 253/12, but that'll do it. Boom. Feeling great. So that's 2 regions. That was a really, really good one to do by hand, so that you can see where things are crossing and where things are not. So man, I really like that one. You guys tell that I just nerd out about this stuff. I really like this section. Now we're gonna do a trig one. So blue is the trig one, and then we'll do another y integration one if you want to see that. And maybe, I don't know, I think it's more helpful to do what I did yesterday on the iPad, but maybe if you can see me look at it sideways here too, that can help. So we'll see what we got. Here's the blue one. So trig coming at us. Y equals -2 secant squared x. And y equals 2 cosine x. But it actually does tell us that we're from 0 to pi over 4, so it doesn't want us to go anywhere beyond that. Let's see if these things meet at 0 and pi over 4, right? If we plug in 0, cosine of 0 is 1, right? Yep. So that's 2. If you plug in 0, you get out 2. Here you plug in 0, well, you're still going to get 1. Squared is 1. Because cosine flipped is secant, so 1 flipped is 1, squared is 1, times -2 is -2. So they don't meet. So let's see here. At 0, this one's at -2, and cosine's at +2. And actually, this I do know, right? If 2 cosine, it just looks like cosine, right? But up 2. And this would be at 2 pi. This would be at pi. This would be at pi over 2. So it's just hanging out up here somewhere at pi over 4. I don't exactly know where. If you plug in pi over 4, that's root 2 over 2 times 2 is root 2. So it's just, this is just this little, since they only want us to go in between 0 and pi over 4, we're just up here. And then this thing, when you plug in pi over 4, you get root 2 over 2. Squared is 2 over 4. No, you just get root 2, and then squared you get 2. you're at negative 4. So this thing goes down to negative 4 by now. So this is literally just, it just wants this piece. Since they're giving us this we just need to know which one was on top, really. Because we just want between 0 and pi over 4. So what's really nice in this case is that by giving us the interval, they set up the bounds for us. And actually, we wouldn't be able to go much farther than that because it doesn't secant. This probably just goes down really steep because it's got a thing in front, but it doesn't secant have the asymptotes. So they're probably telling us this doesn't go much farther than that before it hits an asymptote at like pi over 2. So that's probably why they give us those. And as soon as we know that 2 cosines on top, we're golden because we're just doing 2 cosine minus negative 2 secant squared dx, and this will turn to plus, and we're going to see if we can go backwards. Let's do it. What's backwards from 2 cosine? Isn't it just 2 sine? Yeah, sine goes to cosine. 2's can come out front. We could actually pull a 2 totally out front if we want, since they both have a 2, but that's fine. Backwards from 2 secant squared is just 2 tan, because it's in the derivative of tan secant squared. And then I'm just going to plug in 0 and pi over 4. Oh man, this is going to be awesome. What's sine of pi over 4? Sine of pi over 4 is root 2 over 2. Plus tan of pi over 4 is 1, isn't it? So those are going to cancel, so I'm going to get root 2 plus 2. So that's what I get when I plug in pi over 4. When I plug in 0, sine of 0 is 0, times that's 0. When I plug in 0 to here, 0 tan of 0 is y over x. Shouldn't it be 0 still? Yeah, boom. Root 2 plus 2 is our final answer. That's what it says. I'm digging it. I'm feeling good. Everybody feeling good? Last one. Orange one. Let's see what we got. Yellow one, actually, but I don't have a yellow marker. So y integration. Let's see if we can draw a picture and look at this guy sideways. So here's what they give us, and they don't give us any bounds, so these things intersect somewhere, and we just got to figure it out. So honestly, we're going to want the x by itself anyway if we're doing y integration, right? So I'm just going to do this really quick and add y squared to this side, and I go, oh, as soon as I know that, I'm going to draw the picture over here this time so I can show you how I look at it sideways. I just know that this is the sideways parabola, right, that goes through at 1, 1, at negative 1, 1, and then at 4, 2, 4, negative 2, right? So I know that. Boom. Because that's just an algebra 2 thing. That's the normal sideways parabola. It's the inverse of the one that goes up, reflex over y over x. And then, if I have this guy, 3 minus 2y squared, as soon as I see this minus, I know it's going that way. Right? Because if I plugged in 0 for y, I get x equals 3. So I know, boom, right here x is 3. And then it's opening this way because it's going backwards from that one because it's a negative slope. Oh, you know what? My guess is that it hits right here. Let's verify that. How we verify that is we just say, okay, this is the point 1, 1. Let's plug it in and see if it works. If I plug in 1 here and 1 here, 3 minus 2, 1, boom. And I think it's because it's got a slope of 2 over 1, right? As long as it's not a fraction, that works out in our behalf. And this is negative 1, or 1, negative 1, sorry. So now, here's how I look at these, right? I look at them sideways. So literally, you are tilting your head this way, all right? And when you tilt your head this way, this is on top, which was this one, minus this one's on bottom. So we do this one minus this one. That's really the only thing you need to know. I know it gets confusing to be like, wait, negative 1 to 1, that seems backwards when you're looking at it sideways, shouldn't negative positive? But the rotating thing does mess with you a little bit. You just got to go negative 1 to 1. But this is on top, because this is your positive axis. Alright, so you got to think about the top being your positive. So boom. So we got the integral from negative 1 to 1. And you know you got to use your y's, because it would make no sense to go from 1 to 1, because then you just get 0. And then this one's on top, and you're subtracting y squared, which is on bottom, dy. So it's the integral from negative 1 to 1 of 3 minus 3y squared dy. we go backwards. 3y minus y cubed. Is it that easy? That's awesome. I love that. From 1 to negative 1. Plug in 1 and I'm going to get 3 minus 1, which is 2. Plug in negative 1, I'm going to get negative 3 plus 1, which is negative 2. I subtract those and I get 4. Was that easy? Oh, it was. Except for the setup. It's gross, right? Boom. So there's a few extra problems. Homework questions on Monday, presumably at 10. And then we launch into the last section, but this one was just really important to build on. So had to do 3 days for it. All right, good job, folks.